Today on the bench we have yet another preamp. This one is somewhat different from the last one that I spoke to you about, if you'd seen that, which was the chip preamp, using just chips, no discrete components at all. This is a complete different approach. This preamp is supposedly based on a Marantz JC-2 preamp, and its claim to fame is that it runs in class A. Now, I'm a little puzzled by this because apart from a power amplifier which would clearly have classes, class A, class AB or class D, a preamp generally always runs in class A. I mean, you wouldn't purposely underbias a transistor, or an op-amp for that matter, to run in class B, because why would you do it? You're saving a few milliamps of power maybe, but generally any sort of preamp circuit or low signal amplifier would be basically in class A, which means the current drawn won't vary with power, because a preamp, I appreciate that any transistor is a current device, but in a preamp you're not really interested in current apart from perhaps the final stage so that you can drive it into a relatively low impedance amplifier input. But even so, we're not talking about hundreds of watts of power or anything like this. So I'm slightly puzzled by the circuitry, but I thought I would buy one. It cost me 50 odd New Zealand dollars, which is not cheap. Now, considering this preamp, this is a stereo board by the way, and complete with power supply. It's got everything that you need for power except for a transformer, which we'll talk about in a minute. But it is full of transistors. Well, actually that's not strictly true, because some of these are FETs, and certainly the input is, but I cannot get hold of a decent circuit. There are loads of circuits published on the net, reputedly to be this product, but this particular board I've not been able to get a circuit diagram for, and tracing it, quite frankly, I can't be bothered to trace it through. Now, if you actually do a count, there's 1, 2, 3, 4, 5, 6, 7, and there's another transistor in there, 8. So there's 9, 10. There's actually 10 transistors or FETs per side. Now these big heat sinks here, well, small heat sinks, they are to do with the stabilized supply, and because this is class A, these actually get quite warm. In fact, the two center ones get quite hot, and believe it or not, this is the transformer I'm using at the moment to power this, and it's 15-0-15, and believe it or not, from each rail it draws 112 milliamps at 15 volts, so that's plus or minus 15 volts. AC goes in, and these are part of the stabilized supply. Now, I thought when I was buying this I was actually buying a kit, and it must have been in the middle of the night or something when I ordered this, because this particular version came ready built and very nicely made. The soldering is good, can't fault it, and of course it works. There are two pots on here. I haven't adjusted anything. It's just literally straight out of the box, and there's lots of LEDs, so if you're an LED person you'll love this. There's 4 LEDs. Those two I think are directly to do with the power supply, and one of the adjustments on either side is for getting your plus and minus volts correct. And the other two, I don't actually know what it's for, but I think it's for balancing the stages so you get zero offset, because this is basically a DC coupled amplifier. Bit of focus, thank you camera. There is no capacitors in the input circuitry here, so you must be careful that if your signal has any DC components on it, you do in fact put a capacitor into the input, because when I was testing this previously, my square wave generator puts out DC offset, and it drove the amplifier mad. It just literally, instead of a nice square wave coming out, it was a triangular wave with all sorts of horrible things on it. But I suppose when you feed in 3 volts of offset from the signal generator, you probably would go a bit crackers. So even if whatever your product is that you're going to use on the input has a couple of millivolts offset, I would always fit a capacitor. And the same can be said for the output. It is completely DC coupled all the way through, as you can see here. That's a stabilization across the power supply, that capacitor. So apart from 4 small capacitors, the only other capacitors are these big, rather nice Rubicon capacitors, which are used in the power supply. Well, if you're expecting a preamp to run stone cold, which if you looked at my last video you will see when I reviewed the op amp one, which drew, I don't know, I think it was about 10 milliamps to be sure, something like that. This uses lots of current and things do get quite warm. If you lay your fingers across these transistors stroke FETs here, they are warm to touch, and the 2 big heat sinks here, or the 2 small heat sinks, are not too hot to touch, but you won't want to leave your fingers on there for more than a few seconds. The outer heat sinks just run slightly warm. The power comes in here, and there's 4 very meaty diodes to provide your plus or minus voltage, which I believe is 15. But in the data it says you can use quite higher voltages to run this. I'm just looking on the, they do claim an AC of 15 right up to 24 volts 0.24. Now I would suggest you don't go above 15, because it won't give you anything else other than the fact the heat sinks will get, I would imagine, pretty hot if you've got to drop a good 12 volts across those small heat sinks. Probably not a good idea. The pot used on here is basically right on the input, so it's actually, I don't know what the brand of the pot is because it doesn't say, but it seems to be good and it tracks perfectly all the way through. I've not been able to, if you superimpose the outputs on the scope, you don't see a misbalance at all, so pretty good, pretty good. Now, I'm not going to bore you with loads and loads of sweeps and figures. Well, I'm going to tell you what the figures are, but to actually sit and watch frequency response scanning out is a bit boring once you've seen it once, so I don't propose to do that. But I will give you some figures, and these are figures that's the output, by the way, at just under 1 kilohertz. The frequency response is DC to 38 kilohertz, and that's flat. That's not plus or minus any dB, that's flat. Now, when I tested this, I put a capacitor on the input, as I said, because I had some DC offset on there. But even with the capacitor on there, it's just flat. If you like big numbers, it's actually 1 dB down at 60 kilohertz. So I don't think you're going to be short of HF somehow. But like any good amplifier will naturally have a wide frequency response. If it doesn't have a wide frequency response, it's because it's either non-linear or something in it is wrong. The low frequency, and particularly if it's DC coupled, if it will amplify DC, it will amplify 1 hertz. It's debatable that you'd want it to do that, but this is what it does. I mean, this is what it does out of the box. Initially, I thought the preamp was a little bit noisy in comparison to the op-amp preamp that I spoke about on the last video, but that's not the case. It has quite an insane amount of gain, and if you were going to use this with another amplifier, with another volume pot on the input, it makes sense to have 2 volume controls, because then you can adjust the volume pot on the preamp to match the input level of whatever your product is, and the same way. And then basically you could leave that pot alone, just set it to 1/3 of the way up or something like that, and then use the master volume on your amplifier, or vice versa. But if they're both flat out, you will have an insane amount of gain, and the noise floor will rise, not because it's noisy, but because effectively you're amplifying the noise from the preamp. But when you put it down to sensible levels, it's very quiet. The input sensitivity, for example, 1 volt RMS input will give you 4 volts RMS output. And a sensible input, let's say you feed in something like 370 millivolts, which would be a fairly typical output of most line level inputs. That will give you 1.5 volts output RMS, which will drive pretty well most amplifiers. The one that I was making in my amplifier project, I didn't actually need a preamp because the amplifier was remarkably sensitive, and with the various types of inputs that I chose to use with it, I just didn't need a preamp. But the new project, which I'm working on just out of sight, you'll have to wait for that, the amplifier sensitivity of that is about 1.5 volts, so I will probably need a preamp of some sort. Now this one is probably too sensitive, and you've got all that for nothing, but on the test that I've done so far, it has a very neutral sound, because people always ask me, what does it sound like? Well, if it sounds like anything other than invisible, it's no good, is it? A preamp should be, to quote someone from the distant past, a preamp, or any amplifier, should be a piece of wire with gain. And a preamp, you see it advertised so often. They say, oh, this preamp gives you this, gives you that. If it gives you anything other than higher gain, it's a piece of shit. I mean, it has to be. The favourite one is, oh, it makes the thing sound like a valve amplifier. Well, why on earth would you want to degrade the sound to sound like a valve amplifier? We won't go into valve amplifiers, because if you know me by now, you know that I'm not a great lover of valve amplifiers. Very nice in 1950. Mind you, I was only 1 then, so we won't go there. So any preamp that has any sound, now a preamp cannot make the sound of the amplifier better. It simply can't. It can only and should only amplify what goes in. If it adds anything, it's no good, and you need a different preamp. And I'm quite happy to say that both of the preamps that I've spoken to you about, including this one, has a very neutral sound. And the way I've sort of proved that to myself is to put a changeover switch, balance the levels, and switch the preamp in and out. And I've even asked my wife to do that, so that I'm not conscious of which one I'm listening to, whether I'm listening to the power amp only or the power amp plus the preamp, because you always want things that you make or buy to be better, don't you? You don't want to know that what you bought isn't quite that good. And I've been there and I've done that. These are people that buy $200 speaker cables and convince themselves that they sound better, but they don't. But if I just spent $200 on a piece of wire, I think I would like to persuade myself they sound better. The maximum you can put into this is 2 volts RMS, and that will give you 8 volts RMS just prior to clipping. So basically anything should be able, should be able to drive any amplifier, because I can't imagine many amplifiers need 8 volts. Most amplifiers are less than 2 volts RMS input. So this will drive virtually any amplifier from any line input source, including your telephone, if you have your music on your telephone. For those of you that don't know too much about preamps and things, it will not accept the input from a pickup cartridge, phonograph, whatever you like to call it. It's probably not sensitive enough, because you typically need about 3 millivolts or so into a 47k load. But the main thing is it doesn't have RIAA equalization, and although it will get loud enough, it will sound awful. It will be very tinny and no bass. And bass and treble controls is something this preamp also doesn't have. Now, if you want bass and treble controls, there are quite a few kits on eBay and the like. One of them is a passive bass and treble control. Now obviously if it's passive you're going to lose gain, but you do have more than enough gain, so that's probably better than an amplified system, which is going to introduce more noise, phase shift and nonsense. Well, you're still going to have phase shift with most tone controls. That's another subject, might make a video on that one day, but I don't have any tone controls on this. I use it with FLAC files from my computer, which are a lossless file, for those that don't know. And I use the Music B program for running my music, and there is the facility on there for a degree of tone control. In fact, there's a ridiculous amount of bass and treble lift and cut, plus or minus about 18 dB. But if you use all that, something's very wrong with your loudspeakers. And the other issue with that is if you put loads of lift on, because people have a habit of boosting the treble and bass like that, the biggest problem is you run out of gain and you hit the maximum headroom, and so you actually get distortion from the preamp itself in the computer. So you've got distortion before you even put it anywhere near an amplifier. So if you're going to use tone controls, don't go plus or minus more than 3 or so dB, because if you do, it won't sound as good. And the way to check that, of course, is to switch the graphic equalizer in and out with a flat input, and you'll find that the graphic does colour the sound quite noticeably, even though theoretically it's still flat, the response is still flat, and it is, I've measured it, but it introduces colour, and it introduces phase shift as well, which is noticeable on some pieces of music. So you don't want to do that. Just so you've seen it, this is a 1 kilohertz square wave taken from the output of the preamp, and I've taken a snapshot of it so it's easier to see. But as you can see, there's no overshoot, it's nice and square. In fact, that's as good as my generator can do anyway. That's a square wave of 21.72 kilohertz, and I think you'll agree that's pretty good. If we straighten it out a bit, very slight slope, but try that on a valve preamp, or on a valve anything. Well, we're in the lounge now, and I'm going to give you a little blast of my new amplifier, which I've yet to complete, and the little preamp we've just been talking about. I realise there could be issues here with copyright, so there's just going to be a brief snatch of a couple of tracks and hope we get away with it. This is the new amplifier that I'm building on YouTube, and part 2 will be available soonish. At the moment you can see there's a transformer, and that is not the power supply, that's purely to run the speaker protection board, because at the moment I'm waiting for a transformer to come. Now I'm going to extract the music from my computer. This will be a FLAC lossless file, and I'm using this Topping D10, but please bear in mind this is being videoed from the microphone in my camera, and it doesn't represent 10% of what it really sounds like.